Part 2 of section 2.2 is going to be talking about sketching polynomials. Earlier we talked about the end behavior of polynomials using the leading coefficient test, and then we wrote polynomials based on their zeros. And now we're going to go in the other direction where we have a polynomial. We're going to find the zeros and then draw a sketch. So repeated zeros are zeros that occur more than once. We don't need to list them or graph them more than one time. So for example, we have x minus 2 to the third power equals 0. Now we know we can write x minus 2 to the third as x minus 2 times x minus 2 times x minus 2. So the 0 would appear 3 times, but we only list it once and we can only plot it once. Now when we have a repeated 0, we call that a multiplicity. So a factor x minus a to the k power would have a multiplicity of k, whatever that exponent is. So it's x minus 2 to the third power. Because it's a 3, we'd have a multiplicity of 3. Now, if that multiplicity is odd, we cross the x-axis at that 0. We go through it. Our y values will change from positive to negative or negative to positive. Now, if the multiplicity is even, the graph touches the x-axis but does not cross it. You can think of it as a bounce. That our graph will bounce off the x-axis. So it will either be a minimum or maximum, or we can call it a turning point. When we have an even multiplicity, that x-intercept is a turning point. So graphing polynomial functions, the first thing we're going to do is apply the leading coefficient test, so we know which direction our function goes. Does it go up to the left or down to the left, up to the right, down to the right? Then we're going to find our zeros, our x-intercepts, and plot those. Determine our multiple zero end behavior, so multiplicity, even or odd, and that tells us if we cross or bounce. And then we're going to use smooth curves to connect our points, our zeros. So it says graph the polynomial function. So the degree of this function, if it were in standard form, we would find the highest exponent, but in intercept form, our degree is going to be 3 plus 2, which is 5. So we have an odd degree. Our leading coefficient is negative, so that means our graph will go up to the left and down to the right because we have an odd degree with a negative leading coefficient. So as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. All right, now we're going to plot our zeros, or our x-intercepts. That's going to be positive 2, 0. And this one, there we go, is going to be negative 2, 0. Now the multiplicity for this one was even, so we're going to bounce. And for this one, the multiplicity was odd, so we're going to cross. Right, so I like to draw the end behavior first. So we know that the left side is going to go up, and the right side is going to go down. Now we have to figure out what happens in between. Now at the red one, we said that we are going to bounce, or you can think of it as we should have a turning point at this 0 right here. So our graph comes down, it touches, and if it's a turning point, that means it should come back up, and we have a minimum value there. Okay. Now at some point, this graph has to come back down and touch this blue x-intercept at x equals positive 2. I'm not as concerned about how high or anything you go like that. Just know that it's got to be a smooth curve, that we have to have a maximum at some point and come down. If you wanted to draw it like this instead, that's fine. If you wanted to go up like that, that's okay as well. At some point, we will be also calculating the y-intercept, so you know how high we go. But for now, we're just getting a rough idea of what this will look like. And because we graphed the end behavior correctly, you see at the blue x-intercept, our graph crosses. Our green line goes through it and it crosses. And we should cross because that's what we determined earlier. All right, letter B. We can do the lead coefficient test first before we factor it because this is in standard form, or sorry, general form. So the degree is just the largest exponent, which is 3. And our leading coefficient is -3. So it's a negative leading coefficient. So that means the end behavior is going to be just like the previous example. The left side is going to go up, and the right side is going to go down. Now, in order to get our intercepts, we have to set that equal to 0 and factor. So we can factor out a -3x squared, and that leaves us with x minus 2 equals 0. So then we can identify our x-intercepts. That one in the front, -3x squared, because there's no plus or minus or parentheses or anything, that means it's going to be 0, 0. And that 2, that second power, is an even number, so that means we are going to bounce at x equals 0. And for the pink, this one right here that I underlined in pink, 2, 0, it has an invisible 1 exponent, which is odd, so we're going to cross. So now let's go and plot our points. All right, so 0, 0, I'm going to do that one in light blue, and then I'll do 2, 0 in pink. We know that the left side should go up and the right side should go down from our leading coefficient test. And at 0, 0, we should bounce, which again makes this a turning point. So it's got to come down and then come back up. And then it's got to come back down eventually to touch the pink one. And our graph already crosses there, and we can verify that we should cross at that point. So this would be our graph. Now, if it's bothering you or you're struggling with what to do from this point, and you say, well, how do I know how high to go? Like I said, it doesn't matter. But if you want to, you can just plug in or substitute in x equals 1 or x equals any number to get another point. If that makes you feel better, I'll just show you if we plug in 1 for this. So f of 1 equals -3 times 1 squared plus 6 times 1. Oops, this should be to the third power. So then that gives us -3 plus 6, which is 3. So we have the point 1, 3 on the graph, so we know it's got to come up at least and hit that part. All right, now on the next page, we have 3x squared minus 15x plus 18x. So let's identify that we have an odd degree, so the degree is 3, which is odd, and we have a positive leading coefficient, which means that the left side is going to go down and the right side is going to go up because we have an odd degree and a positive leading coefficient. So now to find our x-intercepts, so we have 3x squared minus 15, 3x to the third. 3x to the third minus 15x squared plus 18x equals 0. We can factor out a 3x, and that leaves us with x squared minus 5x plus 6 equals 0. And then we can factor x squared minus 5x plus 6. That's going to be x minus 3 and times x minus 2 equals 0. So then we have 0, 0. And the multiplicity is an invisible 1, so we're going to cross. Here we have positive 3 comma 0 with, again, another invisible 1 multiplicity, so we're going to cross. And then here is going to be 2 comma 0 with another cross because we have an invisible 1 for multiplicity. So let's go through and plot all of our points, 0, 0, 3, 0, and 2, 0. And I'm going to use the same colors. And we know that the right side goes down and the left side, the left side goes down and the right side goes up. Now, one of the things that I notice students will do with this is that they'll start drawing and they'll accidentally cross the x-axis at a different point. You know, that's why when I draw these x-intercepts, I like to make them very bold so that I know I can only touch the x-axis at those points. So if I'm drawing my graph and I notice that, oh, I touch it here and there, I've done something wrong. So all of our x-intercepts are crosses. So my graph's got to come up, and then it's got to come down and touch this x-intercept, and we have to cross because we identified that right here. So we got to cross, and then we got to come back up and touch the blue one, and you see the graph is now connected. The insides connect with our ends, and we cross at our blue x-intercept, which is what we had listed over here. So if it's very important to identify and understand, do we cross or do we bounce at these x-intercepts? Because that will make our end behavior work out. All right, our last one, negative x squared plus 9x, negative x to the fourth plus 9x squared minus 20. So we have an even degree this time. So our degree is 4, which is even, and a negative leading coefficient, so that means both sides are going to go down. Whoops, that's x equals positive infinity. Y approaches negative infinity, so both ends are going down. And now we have to get our x-intercepts. So then we have negative x squared, x to the fourth, plus 9x squared minus 20 equals 0. We're going to divide both sides by negative 1, so we have x to the fourth minus 9x squared plus 20 equals 0. And then this is that quadratic form where we say what two numbers multiply to 20 but add to negative 9? Well, that's x squared minus 4, x squared minus 5 equals 0. Because we have a fourth power, a second power, and then a no power. It's that quadratic form. We can factor this further to x minus 2 times x plus 2. And then we have x squared minus 5 equals 0. So then we have x equals 2. And it's an odd multiplicity, so we're going to cross. We have x, let's write these as intercepts. Negative 2 comma 0, which is going to be another cross. So back here, let's just change this to positive 2 comma 0. Now with this one, x squared minus 5, because it is not a linear factor, we have to do x squared minus 5 equals 0, x squared equals 5, and then we square root both sides. We get x equals plus or minus the square root of 5. And we're going to get a decimal approximation for that. The square root of 5, second, is 2.24. So that means we're going to have one intercept at 2.24 comma 0, another one at negative 2.24 comma 0. And these each have a multiplicity of 1. Yes, I know there's a 2 right here, but it got us two separate zeros or x-intercepts down here. So these are going to be crosses as well. So now let's plot all of our zeros, and I know that they're going to be rather close to each other. So we have negative 2 and positive 2. And we have negative 2.24 and positive 2.24. And our end behavior, we said both ends are going down, so let's draw that. And we cross at all of these x-intercepts. So I'm going to come up, come down, turn, come up, and come down. So it looks like an M. So again, knowing your end behavior and whether we cross and bounce is crucial. Don't get hung up on, oh, did I go down far enough in between? Was this supposed to go up like this and down like that? Is that how it's supposed to go? That's not what our concern is right now. We want to know just the general shape of what is going on. All right, so thanks for watching. Make sure to like the video and subscribe.